All right, I just wanted to make a quick video to talk about some of the problems on ALEKS this week and go over just a little bit more in depth some of the things we rushed through in class. So on even and odd functions, reminder, an even function is when f of negative x is equal to f of x. What that means is if there's a negative on the inside, we can just destroy it. We can just pretend it's not there if we are an even function. If we're an odd function, that means that we can take a negative that's on the inside and move it to the outside. So this negative on the inside moved to the outside. Or we can take a negative that was on the outside and move it to the inside if we're an odd function. There are two even trig functions, cosine and cosine's soulmate in life, secant. They are both even functions. And then there are four odd trig functions, sine and cosecant, soulmates, both odd, tangent, cotangent, soulmates, both odd. So the problems on ALEKS look a little bit like this. You're asked whether it's even, odd, or neither, and then you have to rewrite each of these expressions using the even or odd property. So secant, we know that secant is an even function, and that means that it destroys negatives on the inside. If we look at this very first problem here, secant of negative pi over 7, because there is a negative on the inside and because secant is an even function, it means we can just ignore the negative. That's it. Because secant is even, secant of negative pi over 7 is the same as secant of pi over 7. And that drop-down menu would have secant of pi over 7 as an option. For tangent, we know that tangent is an odd function, which means if there's a negative on the inside, it can come to the outside. So tangent of negative 42 degrees is the same thing. Take this negative, put it out front as negative tangent of positive 42 degrees. So that's all there is to these ones. That's all it is. Okay. Another thing to mention, so here's another topic from ALEKS this week. Using a calculator to approximate cosecant, secant, and cotangent values. So with these, it says to use the ALEKS calculator, but you can use whatever calculator you'd like. With these, you need to know how to input them into your calculator. So here's the important thing. We knew that sine of theta was the y value and that the soulmate of sine, cosecant, was 1 over the y value. We knew cosine was x and secant was 1 over x, and tangent we said was y divided by x, and cotangent is x divided by y. So while these are all really cool, knowing that sine is y and that cosine is x allows us to rewrite the remainder of these guys with sines and cosines instead of x's and y's. So for instance, tangent is y divided by x. So if y is sine and x is cosine, that means that tangent theta is equal to sine theta divided by cosine theta. Now, this isn't going to be helpful for this problem because we do have a tangent button in our calculator. We don't need to know that. But for these guys over here, this is really, really useful. Okay. So for cosecant, 1 over y, that means that cosecant theta is equal to 1 over sine theta. Secant of theta is 1 over cosine theta. And like I said, this one's not going to be super useful for us right here. Ooh, that wasn't what I meant to do. Is it not going to let me erase without? Okay. What is useful is the knowledge that these two are reciprocals of one another. Tangent and cotangent are reciprocals of one another. So cotangent ends up being 1 over tangent, and that will be more useful when using your calculator here. So if I was trying to find cosecant of negative 2 pi using a calculator, ooh, there we go. Ooh, cosecant of negative 2 pi is the same thing as 1 over sine of negative 2 pi. Which we can plug into our calculator. Secant of 7 pi over 4. Secant's soulmate is cosine, so secant is 1 over cosine. 1 over cosine of 7 pi over 4. So that angle stays the same. Cotangent of negative 280 degrees. Cotangent's partner, soulmate, is tangent, so this is 1 over tangent of negative 280 degrees. I'll go plug those into my calculator real quick. I'm gonna pause the recording while I do that. All right, so I have those values there. Now, these are all special angles, or they're at least coterminal with special angles. So we really could have done this and found exact answers using the unit circle. Unfortunately, because this problem wants our answers rounded to the nearest hundredth, we do have to plug these into a calculator. Really, really important to make sure your calculator is in the right mode. So for these two problems, my calculator was in radian mode. And then for this one down here, I made sure my calculator was in degree mode. All right. An evaluating problem. If theta is equal to 300 degrees, find the exact value of each expression below. Hold on one sec. I'm going to grab our unit circle. Let me pause recording. All right, so here's my unit circle. So we have theta is equal to 300 degrees. We want to find the exact value of these expressions over here, plugging in our theta value. So for part A, sine squared theta, that's going to be the same thing as sine of theta squared. Our theta value is 300 degrees. So this would be sine of 300 degrees squared. If I look over at my unit circle over here, let's see, we have our 300 degree spoke right here. Sine is the y value, so negative square root 3 over 2. Sine of 300 degrees is negative square root of 3 over 2 squared. Negative square root 3 squared is 3. And then 2 squared is 4. So 3/4 would be the value of sine squared theta. B, sine of negative theta. So there's a few ways to go with this. First of all, we know theta was 300 degrees, right? So this is going to be sine of negative 300 degrees. Two ways to approach this. Let me see if I can erase that line and bring this image on down. Option 1 would be making a coterminal angle. So 300 degrees in the positive direction goes to here. Let's see if I can. I was hoping I could pick up that little arrow and spin him around, but I won't be able to do that. So 300 degrees in the positive direction goes this way. 300 degrees in the negative direction goes the same amount, but it's going to go clockwise instead of counterclockwise. Now, the easiest way for us to find an angle that's going to fit on our unit circle would be to just add 360 degrees to negative 300. because they'll lie at the same place. So negative 300 would lie right here. So we should get 60 degrees because it would go like this and it would stop right there. But if we didn't know where it would stop, we could take negative 300, we could add 360 degrees, and then we know that 60 degrees is coterminal with negative 300. Negative 300 is this drawn in standard position, whereas 60 degrees is that, but they both have the same terminal side. So their sine value is going to be the same. So sine of negative 300 degrees is equal to sine of 60 degrees. And sine of 60 degrees, well, that's going to be the y value up here at 60 degrees. So that's square root 3 over 2. That's one way of doing it. Option 2 is to use our even and odd properties. So we're looking to find sine of negative 300 degrees. And maybe we don't want that negative on the inside. Maybe I don't want to make a coterminal angle. Since sine is an odd function, I can take the negative and put it on the outside. Again, because sine is odd. So we have negative sine of 300 degrees. Sine of 300 degrees, let's look for our 300 degrees spoke again. Oh, there it is. So sine of 300 degrees is negative square root 3 over 2. So if that's what sine of 300 degrees is, we have this negative, right? Oop. We have this negative on the outside, that's that one. And then negative square root 3 over 2. Those negatives cancel and you get square root 3 over 2. So either way, you get to the same answer. One of them uses the even and odd properties. The last one is sine of theta divided by 2. Theta is 300 degrees, so this would be sine of 300 degrees divided by 2. So that's sine of 150 degrees. Looking at my unit circle, 150 degrees is right here. Sine is the y value, and the y value is 1/2. And that's that. All right. For our final problem, finding a point on the unit circle given one coordinate and the quadrant. So you're given a point and you're told this point's on the unit circle and you need to find the y value. You have the x value, you need to find the y value. Important thing is that the unit circle is a circle. Circles in general have the formula x minus h quantity squared plus y minus k quantity squared is equal to r squared, where the center of a circle is at h comma k and the radius is r. So in the case of the unit circle, the center is at 0, 0. So h and k are both 0. And then the radius of the unit circle is 1. H is 0, so we don't have this. K is 0, so we don't have this. And then R is 1. So the equation of the unit circle is x squared plus y squared is equal to 1. Any point on the unit circle will obey this equation. So if we have the point negative 3/4 comma y, that means that this is our x value. and we can plug it in for x over here. So we have -3/4 quantity squared. We don't know what y is, we're going to solve for it, is equal to 1. So we have 9/16 plus y squared is equal to 1. We're subtracting 9/16 off of both sides. So we get y squared is equal to, mental math. Is that right? 7? It is, isn't it? It is. 7/16. Taking the square root on both sides, when we do this, we do have a plus or minus still that we need to take into consideration. So we take the square root on both sides, we leave the plus or minus. This will simplify to square root 7/4 because the square root of 16 is 4. To decide if it's the plus or the minus, we look at this quadrant information we were given. So it says that we're in quadrant 3. We know that in quadrant 3, down here, the x and the y values are both negative. So this would be negative. Y is equal to negative square root of 7 divided by 4. I had just paused to make sure that my mental math was correct here, and it is. All right, so that would be the answer. So important thing on this one is this x squared plus y squared equals 1, and then double check the quadrant before you put your answer in. In fact, you should just do the quadrant part at the beginning, right? If you know it's in quadrant 3, that means y has to be negative. Before you even start the problem, you could type a little negative in there and you'd be good to go. Anyway, those are all the problems I wanted to go over. Hopefully this helps a little bit. I hope you have a fantastic weekend, and I will see you again next week. Bye.